Greetings. Welcome to week one. This is our week one video in preparation for us getting together on week one for those who are face to face. Okay, so today we're going to just go ahead and get started. Now, the week one overview content, building the foundation, understanding networks, network models, and how does data flow. This is basically getting the basic terms we're going to be using for the rest of the semester, kind of outlining those and defining those as far as what they do. And then later on, we'll see more specifically how they fit into the whole flow. As we talked about in the introduction, again, to keep things simple, I have data. I am at point A. I want to get that data to point B. Okay. How do I do that? How does data communication and computer networks help me to get that information from point A to point B? What are the various paths and various devices that I have to go through in order to route to the place that I want to be? So that's what we're basically going to talk about here, is laying the foundation for those particular pieces of the network that we're going to have to deal with in order to transmit that information. Okay, so here there are basically 7 sections that we're going to be talking about in this particular week one video. We're going to be talking about an introduction to data communications. We're going to talk about the type of networks. We're going to talk about network topologies. We're going to talk about physical transmission media. We're going to talk about the OSI reference model. Okay, we'll get some detail into that. And we're going to talk about data encapsulation. What do I have? How do I have to label this data as it's going through the network? Okay. Then we'll jump into a few of the TCP/IP models and what that buys us. I know you've heard that term probably several times, TCP/IP. Now we're going to jump in and really do a deep dive into how that works. The journey of a packet. Okay, we talk about getting data from point A to point B. Okay, we'll find that data is transmitted via packets, and that packet goes through certain paths. And so we'll talk about the fundamentals of getting that data, getting those packets. What are the steps that has to go through? And then we have the common network devices. These are the basic terms that we're going to be starting with. Then we'll kind of build on that. And then look at some, real world examples to kind of take that and wrap it up. So there's a lot of information, okay, that in this particular week. I'm going to be concentrating on basically giving you the key things that we want to get out of it. But I wanted to do so in a way that I'm going to be looking, when we look at the diagram, we'll be looking at not only the, say, for example, the land, but we'll be looking at what's around it. Okay. So we won't just be giving definitions. I want you to make sure that you kind of get the context of how what we're talking about fits into the entire picture of network communications. Okay. So there's going to be some information that you're not going to see on the homework. You're not going to see on the quiz, but it's necessary just so you'll be aware of where this particular piece of information fits into the big picture. Okay. Okay, so with that, let's go ahead and get started. Here we're talking introductory data communication. Let's go ahead and do this. Yep. Okay. Okay, so let's look at introductory communications. Let's say so some key things that we want to get across. Point A and point B. Okay, so that we're going to replace point A and point B, and so hopefully from now on we'll be referencing the sender, the message, and the receiver. Okay, those are the key pieces. The message goes across a medium. So here we have a sender, the device that originates the transmission. Message, information that I want to get from the sender, and I want to get that information to the receiver, the device that accepts the transmitted data. And it goes across some medium, whether that's wireless or wired, or we'll be talking about that and how we get, what are the various methods we can get to transmit that data over. So some of the key definitions, data raw facts, information that can be processed into meaningful information. Key thing here is data and communications are two different things. Okay, that's right here. Data has been organized and interpreted. So where we might say that some things we're going to take into consideration for data, okay, really doesn't apply until we transform that into information. Okay, so we got data, information, data communication, network, node, and host. Okay. The expectation here, some of this stuff we'll be kind of rehashing for when we do our face-to-face. But those who are online are basically getting this information, and I'm hopefully trying to get that information that we do, may hopefully be able to Zoom it, kind of internal Zoom, so that the stuff we talk about in the face-to-face class, I'll be able to also give that to you for those who are online. Okay, so this is the basic introduction to data communications. Okay, the 3 or 4 main pieces that we're talking about. Okay, so here we come about network types. I know a lot of you have seen the word LAN, local area network. Okay. In fact, I think LAN, sometimes you forget what it stands for, and LAN becomes the term itself that represents the particular network. But here we've talking about PAN, LAN, WLAN, and MAN, WAN, Internet, okay, Internet, the global network, and then Internet, the private internal network, and then the extranet. Okay. So here, personal area network. Okay, here we're looking like stuff is your AirPods. Your AirPods are connected to your phone. Okay. Or you might have if you're into Apple, an Apple Watch that's connected to your iPhone. Okay, those are PANs. Those are personal networks. Okay. Here we're also talking about LAN, local area networks. Okay, networks that connects devices in a limited area. You could have a local area network in your house. You have your TVs connected to, you have your laptop connected to, you have your phone connected to. Those are basically connected, within a certain small area. Okay, the local area network. Then we have the WAN, the wireless local area network. Here, the LAN uses a wireless technology, Wi-Fi. Shoot. Yeah. There we go. Sorry about that. Okay. A wireless area network. Okay. A LAN that uses wireless technology. Again, we say with a Wi-Fi. It's still local, but we don't have any wires. We don't have anything physical. We're basically transmitting that information by either radio waves or light or some other form like that. MAN, metropolitan area networks. These are networks that connect multiple LANs across a city. Okay, so I can have LANs that say I had 3 universities, okay, in a particular city, and they are connected to each other. We may be able to do that with a MAN, okay, a metropolitan area network. Also, there might be cases, I don't know if you've seen this before, that some cities actually build a metropolitan area network for their city, so that if you're in the city, you can pick up on that LAN, you actually connect to it, to basically use that as a resource that no matter where you are in the city, you'll have a network that you can punch into in order to send and receive information. Okay, a WAN, wide area network. The most common thing here is the internet itself, where I'm basically connecting to various places all over the world. Okay, that's a WAN. Then we got the internet itself, the global network. Okay, let me back up. A network that spans a large geographical area such as countries or continents. That's a wide area network. An example of that, we're moving over into internet. And internet, we have the global network, and we have a private internal network for intranet. Okay, so we got internet, which is basically connecting locations outside of where you are. And we have intranet, which just says that, it's sort of in the form of a LAN, but it's greater. I could have everything that's connected to Carolina University. Okay. And I can make that an intranet. So it's within the university that I'm connecting all the laptops, I'm connecting all the PCs. Okay. That basically I'm creating an extranet of that. Private network used within the organization for communication and sharing resources securely. Extranet is an extension of an internet that provides multiple access to external users, such as partners or customers. I can be in a company that I have contractors that do work for me. Well, I need to get them into our network, okay, in order to be able to pass information back and forth from them. Okay, so I can create an extranet that is locally for my company, but because of the way I work, I must have contractors that I might, employing where they need that information and we need information from them, so I can create an extranet of that information. Okay. So, real world, you connect to your PAN, to your home Wi-Fi, via WLAN, okay, which connects to an ISP, which is a WAN, okay, which accesses a website, which is the internet. So that's kind of how the real world flows. I mean, there'll be some questions in the homework that kind of ask you more about that on where you would see what. Okay, so be prepared for that. The key takeaway, understanding network types helps us choose the right technology for the right communication need. That's a key point. Every thing that we're going to be talking about doesn't apply to everything. Okay. When we talk about a LAN, it does not apply to everything. It's not said, okay, we need to set up communication. Let's set up a LAN. Now, we're going to have to look at it individually as to how and what we need, and then basically looking at the various protocols, the technology, and topologies, and basically pick and say, oh, this is the best one that we need to take. So there's some decision making that we're going to need to do in order to determine which particular types of, say, for LAN communications, which one do we use? Okay, here we're talking about topologies. Okay, these are the various ways I can connect information. We can have a bus topology, a star, a ring. Okay, my expectation is you will go back through these particular slides. They will be available online. And so you look at them, study them. Okay, and then basically these are going to be the backbone for the homework and quiz assignments that you're going to have. Okay, but to kind of introduce you, bus topology, star, ring, mesh, tree, hybrid. Okay, those are the various types that I can pick to put, and I'm going to use the term nodes because nodes, anything that's connected to the network. Each one of these things you see here are considered nodes. They're kind of showing laptops or computers, but anything I can connect to the network is a node. And anything that is a node that's in the network, I can put in one of the topologies we're talking about here, whether that's a bus, a star, a ring, a mesh, a tree, or a hybrid. Okay, these are the definitions for each. We'll be delving a little bit more detail during our normal class, but this basically gives you the highlight information of how nodes are connected together in a network. What are the various ways that we can connect that information? Okay, as far as physical medium, okay, here we talk about the transmission medium. How do we physically, this is physical, how do we physically transmit the information that we want to get from point A to point B or from sender to receiver? Okay, so here we have a twisted pair. Okay, as far as when we would want to use that is here. Coaxial cable, okay, that is another method that we just use. Fiber optic, where we're actually transmitting light, okay, instead of, say, magnetic pulses. Radio waves, microwaves, infrared. Okay. These are all various methods that we can use to physically get information from the sender to the receiver. The physical medium, okay, again, This is really not talking about topologies or lands. This is talking about the physically. What is the medium that I'm going to use to transmit that information from the sender to the receiver? And again, there might be, keeping in mind that there might be different transmission media depending on where we are. Leg 1 to 2 might be a twisted pair. Leg 3 to 4 might be optical. Okay, so that you can't assume that the same media is going to be used from point A of the receiver to point A of the sender to point B of the receiver, and all of them are going to have the same medium. In fact, there's probably 0% chance that the full path that you're going to be using is going to be one medium. Okay, so you're going to have to be aware of what are the various types of physical medium that you may have to be transgressing or transmitting across in order to get your information from sender to receiver. Okay, the OSI reference model. Okay, the OSI Open Systems Interconnect model is a conceptual framework that standardizes the functions of communication systems into 7 layers. Each layer performs a specific task and provides services to the layer above it. Okay, so this particular code, we have 7. We have the application layer, the presentation layer, the session layer, the transport layer, the network layer, the data link layer, and the physical layer. All of these are layers, are different modes that we're going to have to go through in order to transmit the information from the sender to the receiver. Here, we give the main functions of what each we'll have a little more detail, and we'll be looking in class is what's the significance of these. Again, this still applies that if you look at a particular term and you don't know what it is, okay, if I look at these session layer and it says establishes, manages, and terminates sessions, okay, control dialogue between hosts. If there's some term in there you don't know, look it up, okay, look it up. Again, if you look it up and you still don't understand it, then that's when you come and get with me, and then we'll kind of go through it. But these are the layers. These are the functions. Again, each one of these layers is important where I'm getting from the sender to the receiver, and these are the various layers I'm going to have to go through. Okay, here we have something on encapsulation. Okay, we have a slide for that. Okay, here's encapsulation. Encapsulation in simplest terms possible. And encapsulation is saying, I'm going to take this information and I'm going to put it in an envelope. So here, when we're talking about encapsulation and decapsulation, here we're talking about the layers of the using encapsulation using OSI, the 7 layers. I got the data here at the presentation layer. I'm putting it in a presentation envelope. Okay, when I pass it down to the session layer, I'm going to add some more information to put it in the session layer envelope. Think that each step we're putting headers and trailers in the front of that data or in front of that group of data, okay, that has information that I'm going to need that's going to be needed by the next step in the layer. Okay, so that information is basically transmitted from a header and a trailer, and each step is basically taking and adding additional headers and trailers that particular layer is going to pass down to the next layer. That's what we're displaying here. Okay, so the data presentation layer puts a header, session layer puts its header, okay, using the previous data. So here's just, again, we cascade down each time putting headers and trailers into, okay, the various information we're receiving, again, for the purpose of putting all this information, each step being put in an envelope. And this envelope, again, contains information that will be needed down the line as we send the information from sender to receiver. Again, decapsulation, be aware, this is kind of one of those things that, encapsulation is the key definition here, but to put in the scope how that relates to everything within the whole process, once we, as a sender, we send information through the OSA, okay, level layers. Okay, when it gets to the receiver, the reverse has to happen. We have to decapsulate. So we encapsulate, sending information to the receiver. The receiver is taking that information, decapsulating it, and basically getting the information that it is expecting to receive. Okay, TCP/IP protocol. Okay, TCP/IP is a understanding of TCP layers. Here, where the OSI had 7 layers, TCP/IP has 4 layers. You have the application layer, transport layer, internet layer, and the network access layer. So these are the 4 areas. As far as what IP is internet protocol, TCP/IP is transmission control protocol. Again, sometimes we kind of merge these together and we say TCP/IP, okay? And that, in essence, becomes the model. But really, there are 2 pieces. There's the internet protocol, and separate from that is the transmission control protocol. Protocol. Okay, so IP, TCP/IP, and then UDP. This is just a special version that, and my apologies, I get fat fingered here. Okay. As far as the information for UDP is just a way that I can transmit data without putting all those headers that they've basically been talking about with OSI, and be able to transmit that information faster. So, but we'll find that later on that that's not really the best method to use, even though you might be able to get something faster. The key point is it's not guaranteed to get there. Okay, which kind of defeats the purpose of what you're sending. But again, if you're basically looking at speed, okay, we'll kind of discuss what where that might be an advantage when we talk about this face to face. But here, the key points here is, IP, TCP/IP, UDP, HTTP, and HTTPS. When we go to a website, okay, your domain names system, how do we identify? We have a node. Each one of those nodes becomes a domain name. That domain name is basically converted, okay, to an IP address. And based on that IP address, that's where we're going to be kicking in the TCP/IP discussion here. So again, look over this, read it in detail. Okay, we will be ready to discuss this in the face-to-face class. The journey of a packet, okay, just going through the steps. Again, there's information that we're going to delve into detail. For example, when we talk about networks, we're going to do a deep dive. But service hosts, okay, the local network. We're going to talk about the switch, and I keep getting fat fingered, and I apologize. Okay, journey of a packet. So local network, okay, goes to a default gateway, which we call a router. Internet goes to router, sends the router from one router to another router. Destination network. Okay, it basically is received by the destination network, which basically sends it to the local network of the sender. Destination host is web server, and then response back to you. So basically, this is looking at going through all the physical mediums that a packet of data would go through to get from the sender, which is you, to the receiver, which is who you want to send it to, and what happens once that information is received by the receiver. Okay, here is another summary explanation. Application data creates data, transport layer breaks it into segments, network layer adds IP address header, data link layer adds the MAC address. We'll be delving into the MAC address a little later. And physical layer converts bits to signals and transmit it over the medium. Okay, So those are basically the steps that we go through. Again, each one of these in itself is probably a course. Okay. So, am I expecting you to know the details of the application layer, transport layer? No. What I am expecting you to know is that each one of those layers has a particular function. Okay. And what happens in that function, you should be able to describe what happens. You may not be the engineer that actually puts that piece together, or for the specific transmission of when the information goes from the application layer to the transport layer, and what is the physical protocol that goes with that. But I am expecting for you to know that, yeah, application is going to produce data, and it's going to go to a step called transportation layer, which breaks that information up into pieces. Okay, so that's the level I'm wanting you to be able to understand what's happening here. Okay. Okay, so here, okay, so again, looking at this, understand the process. Understand the process. Okay. Okay, common network devices, we're going to be hitting them. You're going to hear them. You're going to hear them again. You're going to hear them again. So, yeah, I'm expecting you to know what's happening here. I expect you to know what a router is. What is a switch? What is a hub? What is a wireless access point? Okay. What is a modem? Most of these things you've already seen. Okay. Most of these things, especially when you talk about a modem or maybe a router, okay, you've come in contact with that in basically building your LAN or connecting to a LAN that you might be using. For example, Carolina University, as far as you might be at home and you have a modem to connect into it. Okay. So this is what we're talking about: the router, the switch, the hub, wireless access, the modem, the firewall. What's preventing someone unauthorized to getting to information, okay, through your network. Okay, the firewall. Again, we'll be delving into that. Network interface card. Okay, a NIC card, a repeater, okay, a bridge, and a server. Again, these are 10 different items, okay? Then look at it, look at the definition that we've specified here on what each does, and understand that these pieces, I'm going to pick number 1, and I'm going to pick number 3, and I'm going to pick number 8, okay, in order to get my data from point A to point B. I want you to be able to understand at that level, okay, that when I use a switch, I'm using the switch to do this. Now, I'm not really looking at specific, how does the switch work, but I am looking for you to know that if I need to basically route information from one way I thought I was going to route it to the next way I'm going to route it, I went to a switch, which basically sent that information to a different place. Okay, so read over this, okay, and understand the common network devices that can be used in the development of a network. Okay, this is just looking at another way. We're going to basically be discussing this in more detail. Just kind of highlight one of the things we're going to be doing when we meet face to face is we're going to go over the homework. We're going to go over the quiz, okay, to make sure everybody understands what we're supposed to do. And then we're going to basically take and go and look at what you should have already seen based on the online video, kind of go through the details that support that information so that you can do the homework and you can do the quiz. And of course, the project, okay? The project that you will have each week is coming from the lab. So keep that in mind. That's the way our things are going to be handled right now. So that's the last screen. So take this. You need to read it. By the way, okay, as I told you, be prepared to have a small quiz, okay, on the fact that you looked at this information. Okay, there will be expectation is that you are going to basically video, listen to it, read it, each day, so that by the time we get to Thursday, okay, that information you've already covered, and basically we're just going to be filling in the holes. Okay. So expect to have a small quiz in class, closed note, closed book, which basically is the highlights of the things that we mentioned we're going to be needing for week 1. Okay. Okay, so that's it. I hope everybody has a great rest of the week, and we will see you on Thursday. Have a good one. Bye.